Hi, Assalamualaikum. My name is Muhammad bin MAZLAN. Today I'm going to present about this chapter. For the introduction, this article explores the pipe water quality in UTHM Pago Residential College after the filtration process. Generally, humans require clean water to consume in order to prevent the adverse health effects produced by pollutants in water. Therefore, water treatment is required to obtain clean water. One of the water treatment process is filtration. The objectives of this study are to produce a water filter which consists of fine sand, gravel, zinc and copper, with analyzing the result of pH test, biochemical oxygen demand test, total suspended solid test, and ammoniacal nitrogen test on the filtered water. Fine sand, gravel, zinc and copper are used as the main composition for the drinking water filter. Quality of filtered water is better than ordinary pipe water. Next, we go into the problem statement. The water from taps was passed through in a few treatments at the water treatment plant before being distributed to UTHM Pago Residential College to make sure that the water is safe to use but the water is not suitable for direct drinking purpose. So, the problem are the residents cannot drink the water directly from the taps because of rust from old pipes get mixed with the water. Damaged pipes could let soil and other contaminants enter the water. Water in old and leaking pipes could accidentally mix with sewage from leaking drainage pipes and become dangerous for drinking, and stagnant water in pipes become a breeding place for bacteria. So, the water filter must be produced to overcome all of these crises. Finally, the scope of project. The location of this project is in UTHM Pago Residential College. To make this project successful, a few experiments must be done to determine the water quality of the water taps. The tests are biochemical oxygen demand test, pH test, total suspended solid test, and ammoniacal nitrogen test. For the water filter, we use fine sand, zinc, copper, and gravel as the elements to filter the project and a few tools to produce it. We also consult the water quality of tap water by Malaysian Drinking Water Quality Standards. Then, the objective of research is to produce a water filter by using fine sand, gravel, zinc, and copper. Second, to analyze the result of biochemical oxygen demand test, pH test, total suspended solid test, and ammoniacal nitrogen test on the filtered water and compare with Malaysian Drinking Water Quality Standard.
Assalamualaikum warahmatullahi wabarakatuh. My name is Khairil Hasifuddin bin Khairudin. My matrix number is AA210848. Chapter 2 is about the material we use and the water quality index. First material is fine sand. Tipid sand, a granular material composed of finely spilled rock and mineral particles. Sand is available in a number of compositions, but its grain size is what sets it apart. Sand grains are finer than gravel grains, whereas silt grains are coarser. Sand can also refer to a type of soil or a texture class of soil, such as one with more than 85% sand-sized particles by mass. Fine sand is a sand soil texture with particles ranging in size from 0.05 mm to 0.25 mm. Sand filtration is used for the removal of suspended matter as well as floating and sinkable particles. The wastewater flows vertically through a fine bed of sand or gravel. Particles are removed by way of absorption or physical encapsulation. Next, copper-zinc. Copper-zinc water filtration is a high-purity pressed water filtration technology that depends on the redox potential of dissolved oxygen in water when a zinc is anode and a copper is a cathode. It reduces dissolved pollutant in water to more physically innocuous chemicals by using them as component substrate. Copper-zinc water filters are not typically utilized in the residential environment until supplement with carbon-based system due to intrinsic limits in bactericidal and antiprotozoal action and poor filtering of organic pollutants. They can also be used to increase the life of carbon-based filtering system for wastewater effluent in the industrial context. Next, gravel. Clean and safe drinking water is one of the basics of life. Water has become a major global issue. Sand and gravel filters are simple, accessible technology that remove bacteria and other small particles from water. Gravel can be used for water filtration. Gravel acts as a natural filter that retains precipitation that may contain impurities and other sand-sized particles. The angularity and hardness of gravel make it resistant to water erosion. The Water Quality Index is a measurement used to assess the quality of water. The National Water Quality Standard was created to aid in the identification of water quality based on a single criterion, and this is the table Drinking Water Quality for Malaysia and Water Quality Index classification.
Assalamualaikum, my name is Muhammad FAIZ bin Muhammad FADZLI. So I'm going to explain for this chapter 3. This chapter will go through the steps involved in making a water filter. There are numerous approaches that may be used during the experiment to finish the study as a consequence of the objectives and analysis from prior investigations. The water filter consists of fine sand, zinc, copper and gravel. The BOD test, pH test, TSS test and NH3N test are covered in this study. Firstly, fine sand. Use a cleaning brush to clean the sieve of the sieve shaker if any particles are caught in the openings. Keep track of the weight of each sieve and receiving pan. Next, dry the specimen in the oven for 3 to 4 minutes to obtain a dried specimen weight and record the specimen weight. Then arrange the sieves so that the sieve with the smallest openings is at the bottom and the sieve with the largest openings is at the top. Place the weighted specimen on the top sieve and then place the entire sieve stack on the sieve shaker. Then let the shaker run for 5 to 10 minutes. Lastly, take the sieve stack out of the shaker and weigh each sieve and receiving pan separately. Next, zinc copper, KDF. A KDF material contains 50% each of high purity copper and zinc particles. The mixed particle volume gradient ranges from 0.146 to 2 mm. Next, gravel. Gravel has the ability to hold back precipitates containing impurities, which make it an extremely effective filter media. It has high uniformity in terms of angularity and hardness. The maximum size of gravel used will be 6 mm. Next, preparation of water filter. First, insert 0.5 kg of the fine sand into the water hose. Tighten the water hose at both ends with clips to avoid the sand flowing out of the water hose during the filtration process. Next, start filtering the water by attaching the water hose to the source of water. And lastly, repeat the process by replacing the fine sand with zinc and cuprum and also the combination of fine sand and zinc and cuprum into the water hose. Then we go through the sample testing. Firstly, BOD test. Prepare the calculated BOD sample 400 mg per liter influent and 63 mg per liter effluent. Next, label 6 units of 300 ml BOD bottles separately. One bottle is for the blank and the other is for the sample. Fill each bottle halfway with dilution water and add the volume of the sample size calculated. Except the blank bottle, fill the bottles to the brim with diluting water. Next, calculate the initial dissolved oxygen for each bottle and keep track of the results. Insert the bottle stoppers and fill each bottle to the top with dilution water around each of the bottle stoppers. Then, incubate the remaining bottles for 5 days at 20 Celsius in the incubator. Lastly, determine the final DO content of the incubated bottles at the end of exactly 5 days, and then record the result. Next, pH test. Firstly, stir the water sample vigorously using a clean glass stirring rod. Then, pour a 40 ml 5 ml sample into the glass beaker using the watch glass for a cover. Then, let the sample stand for a minimum of 1 hour to allow the temperature to stabilize, stirring it occasionally while waiting. Measure the temperature of the sample and adjust the temperature controller of the pH meter to that of the sample temperature. Then, standardize the pH meter by means of the standard solutions provided. Temperature and adjustment must be performed as stated under Step 3. Then, immerse the electrodes of the pH meter into the water sample and turn the beaker slightly to obtain good contact between the water and the electrodes. The electrodes require immersion 30 seconds or longer in the sample before reading to allow the meter to stabilize. Then, read and record the pH value to the nearest tenth of a whole number. Lastly, rinse the electrodes well with distilled water. Then, dab lightly with tissues to remove any film formed on the electrode. Next, total suspended solid test. Firstly, put a filter paper in the desiccator for a few minutes to allow the silica gel to absorb the moisture. Then weight the filter paper and record the reading. Place the filter disc on the furnace base and clamp it in place. Pour 5 ml of water sample through the filter disc and let it flow. To eliminate all traces of water, turn on the vacuum pump and continue the suction. Dry the filter paper for an hour at a temperature of 103 to 105 Celsius in the drying oven. After 1 hour, remove the filter paper from the drying oven and cool it in the desiccator to achieve the balanced temperature. Then, calculate the solid weight by weighing the filter paper. After that, insert the filter paper in the furnace for 15 minutes to add 500 plus minus 50 Celsius. Place the filter paper in the desiccator after it has dried. Lastly, calculate the weight of the volatile solid by weighing the filter. Lastly, ammoniacal nitrogen test. First, prepare the sample by filling a mixing cylinder to the 25 ml line with the sample. Prepare the blank by filling a mixing cylinder to the 25 ml line with the deionized water. Add 3 drops of mineral stabilizer to each mixing cylinder. Place the stopper on the mixing cylinders. Invert the mixing cylinders several times to mix. And then, add 3 drops of polyvinyl alcohol dispersing agent to each mixing cylinder. Put the stopper on the mixing cylinders. Invert the mixing cylinders several times to mix. Use a pipette to add 1 ml of Nestle reagent to each mixing cylinder. And then put the stopper on the mixing cylinders. And again, invert the mixing cylinders several times to mix. Let the shaker run for 5 to 10 minutes. Pour 10 ml from the blank cylinder into a sample cell. When the timer expires, clean the blank sample and start program 380 and ammonia Nestle and insert the blank into the cell holder. Click 0, the display shows 0 mg per liter. Pour the 10 ml from the sample cylinder into a second sample cell. Clean the prepared sample cell and lastly insert the prepared sample into the cell holder and click read. Then result shows ammoniacal nitrogen in milligram per liter. And that's all from us for final project chapter 1. Thank you so much.